Welcome to Study Loop.
So in this problem, we are given with the decomposition reaction of hydrogen iodide, which will give us hydrogen gas and iodine gas. And we are given the forward reaction rate constant and the reverse reaction rate constant at 700 K. And in first part of this question, we have to find out the value of the equilibrium constant Kc. And then we are also given the forward and backward or reverse reaction rate constant at 800 K. And from these values, we have to find out if the forward reaction is exothermic or endothermic. So first we'll find out the value of Kc. So to do that, what we have to do is we have to write down the forward and reverse reaction rate for this reaction at 700 K. So the forward reaction rate for this reaction will be Kf times H time, and the reverse reaction rate will be Kr times the product concentrations, which are the reactants of the reverse reaction. So the rate equation is basically the rate constant times the reactant for each reaction. So for forward reaction, the reactant is Hi. That's why the forward reaction rate equation is K, the forward reaction rate constant times the reactant concentration. And for the reverse reaction, the rate equation is the reverse reaction rate constant times the reactants for the reverse reaction. And at the equilibrium, these two rates are equal. That means we can place an equal sign between them. And now if we rearrange them, we can write Kf over Kr will be equal to H2 and I2 concentrations over Hi concentrations. And we know that this is the expression for the equilibrium constant Kc. That means this ratio is our Kc. So if we just, so from here we can write down Kc is equal to Kf over Kr, and we're given these two values at 700 K. So if we just put these values, 1.8 times 21 minus 3 over the Kr, which is 0.063. So this will give us the value of 0.028. So this is the value of the Kc, or the equilibrium constant, for this reaction as at 700 K. So that is our answer to the first question. Now in second question, we have to find out if the forward reaction is exothermic or endothermic based on the Kf and Kr values given at 800 K. So what we will do, we will find out the value of Kc at 800 K, and then we'll compare this with the value of Kc at 700 K, and based on that we'll be able to say whether or not the forward reaction is exothermic or endothermic. So the Kc value at 800 K again will be Kf over Kc. So the Kf value at 800 K is 0.097, and the is Kr, Kf over Kr. So and the value of Kr is 2.6, and this will give us a value of 0.037. So now if we compare these values, so this is the Kc value at 800K. At 700K, the Kc value is 0.028 at 700K. That means from here you can see that increasing the temperature is increasing the value of Kc, and we know that if with increasing temperature the value of Kc increases, means um, the concentration of products are increasing, since from the Kc expression we know that on the numerator we have the product concentration. That means if the value of Kc increases with temperature, that means with the temperature increase, we are increasing the concentration of the products, and that means the forward reaction is favored by the increase of the temperature. And we know that if a reaction is favored by the increase of temperature, that means the reaction is endothermic. So from this comparison of the Kc values at the two different temperatures, we can say that the forward reaction here is endothermic.